In today's video, we'll dive into the complex world of rare earth mining and its significant impact on our environment. Rare earth elements, REES, are essential for modern technology, but their extraction comes with serious environmental and health repercussions. From toxic waste and radioactive contamination to air pollution and ecosystem destruction, we'll explore the multifaceted challenges posed by this industry. Join us as we uncover the deep-seated issues within the rare earth supply chain and discuss potential solutions to mitigate these impacts. 1. Understanding rare earth elements, REES. Rare earth elements, often abbreviated as REES, are a collection of 17 metals that have become indispensable in our modern world. These metals include lanthanum, cerium, neodymium, and dysprosium. They play a significant role in the production of various high-tech devices, including smartphones, electric vehicles, wind turbines, and even military equipment. Despite their name, these elements are not particularly rare in the Earth's crust. However, they are rarely found in concentrated forms, making their extraction challenging. This group of metals is essential because they have unique magnetic, luminescent, and electrochemical properties, which are critical for advanced technological applications. Without these elements, many of the devices that we take for granted could not function as efficiently or might not exist at all. 2. The extraction process. A closer look. Mining rare earth elements involves extracting ore from the Earth's crust and then processing it to isolate the desired metals. This process often involves open-pit mining or underground mining techniques. Unfortunately, these methods can release a host of toxic substances into the environment. Heavy metals and radioactive materials are just a few of the harmful byproducts that can be released during the extraction process. Open-pit mining, in particular, is known for causing significant environmental disruption as it involves removing large swaths of earth to access the minerals. The processing of these ores also requires significant amounts of energy and chemicals, further contributing to environmental degradation. This extraction process highlights the delicate balance between technological advancement and environmental stewardship. 3. The problem of toxic waste. Rare earth mining is notorious for generating vast amounts of toxic waste. This waste often includes acidic wastewater, tailings, and sludge, all of which have the potential to contaminate nearby water sources and soil. Such contamination poses significant risks to local ecosystems and communities. The acidic wastewater can alter the pH of water bodies, making them inhospitable for aquatic life. Additionally, the heavy metals and other toxic elements present in the waste can accumulate in the food chain, affecting both wildlife and humans. The management of this waste is a significant challenge, as improper disposal can lead to long-lasting environmental damage. Communities near mining sites often bear the brunt of these environmental impacts, facing potential health risks and degradation of their natural resources. 4. Radioactive contamination risk. Certain rare earth ores contain trace amounts of radioactive elements like thorium and uranium. When these ores are mined and processed, they can release radiation into the environment. This contamination can affect the air, water, and soil, leading to long-term health risks for both people and wildlife. Radiation exposure is a serious concern, as it can lead to various health issues, including cancers and genetic mutations. The presence of radioactive elements in the waste also complicates its disposal, as it requires special handling to prevent further environmental contamination. This aspect of rare earth mining underscores the need for stringent safety measures and monitoring to protect both the environment and human health. 5. Water consumption and pollution concern. The process of mining and processing rare earth elements is highly water-intensive. Large quantities of water are necessary to separate the rare earths from the ore. However, the wastewater generated during this process often contains toxic chemicals, such as sulfuric acid and cyanide. If not properly managed, this wastewater can lead to significant water pollution. Contaminated water can affect local communities by degrading drinking water sources and harming aquatic ecosystems. The high water consumption also raises concerns about the sustainability of rare earth mining in water-scarce regions. Efforts to manage and recycle water used in the mining process are crucial to mitigating these environmental impacts. 6. Ecosystem destruction from mining activities. Mining activities, especially open-pit mining, can lead to extensive habitat destruction, deforestation, and soil erosion. These disruptions can have devastating effects on local ecosystems, affecting plant and animal species that depend on these habitats for survival. Deforestation not only destroys the habitat but also contributes to carbon emissions, exacerbating climate change. Soil erosion can lead to the loss of fertile land, impacting agriculture and local food security. The fragmentation of habitats can also lead to a loss of biodiversity, with some species facing the risk of extinction. The environmental costs of rare earth mining extend beyond the immediate area, affecting global ecological balance. 7. Air pollution and its effects. The mining and refining of rare earth elements can release particulate matter, dust, and volatile organic compounds, VOCs, into the air. These pollutants contribute to poor air quality, which can lead to respiratory problems for nearby communities and workers. Exposure to these airborne pollutants can exacerbate conditions like asthma and other respiratory diseases. The dust generated during mining operations can also settle on vegetation, affecting plant growth and agricultural productivity. Reducing air pollution from rare earth mining requires implementing dust control measures and adopting cleaner technologies in the extraction and processing phases. 8. Health risks for workers and surrounding communities. People working in rare earth mines or living in nearby areas face significant health risks due to exposure to toxic chemicals, radiation, and dust. These exposures can lead to respiratory diseases, cancers, and other health issues. Children and pregnant women are particularly vulnerable to the harmful effects of these pollutants. Long-term exposure can result in chronic health conditions, reducing the quality of life for affected individuals. Addressing these health risks requires implementing strict safety standards and providing regular health monitoring for workers and communities. Ensuring access to healthcare and information about potential hazards is also critical in mitigating these risks. 9. Global supply chain and environmental concerns. The environmental costs of rare earth mining are often concentrated in countries like China, which is the leading producer of these elements. In many cases, the pollution and environmental degradation in these regions go unnoticed or are not adequately addressed due to weak regulations. This situation highlights the global disparity in environmental standards and the need for international cooperation to address the environmental impacts of rare earth mining. Consumers and industries worldwide benefit from the products enabled by rare earth elements, yet the environmental burden is disproportionately borne by a few regions. Strengthening global supply chain transparency and accountability is essential to ensure sustainable and ethical sourcing of these critical materials. 10. Efforts to mitigate environmental impact. There are ongoing efforts to reduce the environmental impact of rare earth mining. These include improving the recycling of rare earth materials, developing greener extraction methods, and enforcing stricter regulations. Recycling can help reduce the demand for newly mined materials, thereby minimizing the associated environmental damage. Research into alternative extraction techniques aims to lower the environmental footprint of mining operations. However, significant challenges remain in balancing the need for these materials with environmental protection. The transition to more sustainable practices requires collaboration between governments, industries, and communities to ensure that technological progress does not come at the expense of the planet's health.